Complex numbers can be a bit of a confusing subject. However, understanding them is critical if we're going to use them in tools like the Fourier transform. If mathematics is the language that the Fourier transform algorithm is written in, then complex numbers can be thought of as a sort of dialect of that language. Broadly speaking, they follow the same set of rules as regular numbers, but they go about it in a slightly different way. For example, just as we can use the four mathematical operators addition, subtraction, multiplication and division with regular numbers, so we can use them with complex numbers as well. It's just we have to keep the real and the imaginary part of the calculation separate. As we'll find out later in the series, this can sometimes make the calculations a little bit more complicated, and we need all sorts of little tricks to try and find our answer. But for now, I'm going to start from the basics and ask, how do we add two complex numbers together? The two operations that we're going to need to do again and again in the Fourier transform are adding and multiplying. So let's first add together two complex numbers. Let's add 3 plus 4i and 9 plus 2i. To do this, we need to group together the real and imaginary parts of the number. The 3 and the 9 are real, so we group those together. The 4 and the 2 are both multiplied by I, so they are imaginary. So let's rewrite the sum as 3 plus 9 and 4i plus 2i. Well, that's easy to do. 3 plus 9 is 12, and 4i plus 2i is 6i. So the result is 12 plus 6i. Subtraction is just as easy. Let's subtract 9 plus 2i from 3 plus 4i. Again, we group together the real and imaginary terms. 3 minus 9 is minus 6, and 4i minus 2i is 2i. So the result is minus 6 plus 2i. So to work with complex numbers, we have to group all the real terms into one group and all the imaginary terms into another. When doing addition or subtraction, it is quite obvious to which group each number belongs. However, as we'll find out in the next video, when we try multiplying two complex numbers, this separation becomes a little less clear. Have you ever wondered why I is the square root of minus 1? Find out in another of my videos. If you'd like to know how complex numbers are used in the Fourier transform, then check out my course on how the Fourier transform works. Please consider supporting the making of these videos by becoming a patron.